Okay, alkene. What's different from alkene and alkane in the name? How it's spelt "een" at the end. What did you notice about alkanes at the end? I'm not sure why this is not. Last unit we talked about alkanes, right? And they were all called, give me an example of an alkane's name. Butane. Give me another example. Pentane. Give me another example. Methane. And they all ended in anes, but you had meth, eth, pro, bute, etc. No e at the end, that's just a flick of my pen. Etc. And they all ended in ane, ane. You're still talking. Whoever's muttering. Ane and ane. And so what we're going to do is we're going to change the name so that they don't end in ane anymore, but rather they're going to end in een, because we're now going to be talking about alkenes. Do you get it? Okay. They're general. Why? Really? No pens going? Because you're so going to remember this for your final, which is in 3 weeks' time. You're going to remember exactly what I said? Okay. General formula is CnH2n. What's the general formula for alkanes? What's the alkane general formula? Plus 2. They differ by 2 hydrogens. So here we had C8H18. Here we're going to have C8H16. Emilio, can you take your folder off of your desk so I can see whether you're writing or not? Yeah, thanks. Does that make sense, you guys? Okay, so it differs by 2 hydrogens. Why does it differ by 2 hydrogens? Because you're going to have a double bond in there. And if you have a double bond, then 2 of the carbons have a double bond between them. Here's another one, here's another one. So how many hydrogens can this carbon have on it? How many hydrogens can this carbon have on it? Just 1. It's already got 1, 2, 3 sticks. So now it can have 1 stick. Whereas in the last butane, or bute example we did, how many hydrogens on this carbon? 2. And how many hydrogens on that carbon? And now this is 1 and this is 1. So how many hydrogens are we less? 2. And that's why the general formula has taken out that extra 2. Does that make sense? So it's CnH2n plus 2 minus 2. So CnH2n. Okay? So this here has a double bond in it. It's given the formula C2H2 times 2, which is 4. This is what it looks like. Have you seen this before? Have you seen that before? Where? In your Vesper diagrams? What Vesper diagram does it have then? What Vesper shape does this have? Trigonal planar. It's one or the other. One or the other. No, not tetrahedral. It's either that one or pyramidal is the one that people mistake up. So this is trigonal planar around each carbon. Right? Around each carbon. What else do you know about this molecule? It's nonpolar. What else do you know about that molecule that you've seen before? Could you draw the dot and cross diagram for it? You have done the dot and cross diagram for it before. Right, try. See if you remember your dot and cross diagrams from your bonding unit in terms of double bonds. Just look like that. A full line of kisses and hugs, and then between the two carbons. Okay. And then XO and XO. Does it matter if my hydrogens are like this, or if they are like this, or if they are one on top and one on the bottom? Does it matter? No. It only matters if they ask showing its Vesper shape, then we have to make it do this little Y thing. Then that's showing Vesper shape. We can't just go up and down. Okay? Can't make it look like a T, it doesn't look like a Y. But if you're not asked to show Vesper shape, then it doesn't matter which way. Do you remember? Okay. Do you remember what it was called? We did name it way back when, but now you can probably figure out the name. What's it called? This. What's its name? How many carbons? F. How many carbons are in there? 2. What do we call 2 carbon chains? F. There's a double bond in here though, so we are, remember that thing we wrote down there? We are changing the ending to ene. You see that? And do you know polythene? Or maybe you probably say it differently here. Probably say polythene? Polythene? Polythene bags? No? Safeway bags, plastic, Safeway bags are polythene bags, which they started with using ethene molecules, and you join a whole bunch of them together to make many ethene molecules joined up together, and that's a polythene bag, which is your normal plastic grocery bags. So where do plastic grocery bags come from? You already kind of knew. Crude oil. Did you know crude oil made plastics? So there you go. This is how they do it. The ethene becomes polyethene, and that's your plastic. That's one example of one type of plastic. But you can see how you started with a hydrocarbon, which of course must have started from crude oil. Okay, so that's how they make crude oil into plastics. Nylon is made the same way, polyester is made the same way, PVC, polyvinyl chlorine, you know, PVC pipes, those are the drain pipes that are quite, or PVC doors and windows, or your plastic doors and windows. They don't look plastic, but they are plastic. They do look plastic if you really look at them, but they're sturdy hard, right? Okay, so polyvinyl chlorine, vinyl is 2 ethenes. So this, I think it's just 1 chlorine. You guys have heard of PVC? That is the starting point for PVC plastics. What would you call that? What do you think that's called? That named? What do you think that's named? Pardon me? What did you say?
It was wrong.
What did you say?
Chloroethene.
You're right.
Okay. That's good.
Chloro, because here's a branch. Here's my longest chain. It's got 2 carbons on it and a double bond. Chloroethene. And ethene is, vinyl is another thing that they use for ethene in like normal speaking, you know. So polyvinyl chlorine or PVC piping starts with that. Okay, nomenclature. So nomenclature means what? Naming. Memorize that. Because on your test, you'll have, what is the nomenclature for the following? And you'll be like, I don't know what nomenclature is. I'll be saying, well, you've seen it a million times. I'm not telling you what it is, right? But instead you look at your friend, the friend's naming it, so you name it. As opposed to looking at what the question's asking you on your homework or on the worksheet. It's really important you read the question and you kind of go, well, that's how I'm supposed to know to start this way. Okay? Right, so just let me scroll down somehow. Oh, I can't. There we go. Okay, so we're going to use the ending "ene" to indicate the presence of a double bond. We still again find the longest continuous chain, so this is no different. But here, the longest continuous chain must have the double bond in it. Okay? So sometimes it's not the very longest. as long if it has to have, or do you remember one instance where you could have gone left or right? It didn't really matter, it still ended up with hexane. This way you would go right if the double bond was right, not left, for example. Okay? Then again, you number the chain, but pay attention to this. You want the double bond to have the lowest possible number. And the branches. Okay, so there's 3 things that you're going to number. So you want to make sure all 3 of them have the lowest number occupied. Okay, and then I'm going to actually skip to these examples here because I like these ones better. So I'm going to go to the next page here. Okay. Find this number 2A. Here we're given this being hexane. Okay? Except for this molecule here is slightly different but the same, so an isomer, to this molecule. H2C double bond CH bond CH2 1 2 3 4 5 6. Do you see how these 2 molecules are the same but different? That you would actually have to break that stick and put it in over here if you're making this. Do you see that? And if I said build hexene, if I said build hexene to the general, to the classroom, some of you would put your double bond here, some of you would put your double bond there, some of you would have put it down there or there. Everybody see how we could have had different molecules of hexene? And then it'd be like, all right, everybody hold your molecules together. They should look exactly the same because they're all hexene. And you lift them up, and I'm like, oh, you've got your double bond in the beginning, you've got it in the second bit, you've got it in the third bit, you've got it at the end. Huh. Now the end and the beginning, can you see how those are actually the same molecules? So you guys have built the same molecule, just turn yours around. Oh, now they look exactly the same. But these molecules aren't going to look the same. This guy that's built at the end and this guy that's built in the middle, you can't overlap or they'll always look a bit different. So we have to call them different names. Okay? So the only thing that's different about them is where that double bond is. So I've got to identify the number in where that double bond is. So carbon 1, carbon 2, carbon 3, I'm still counting from left to right or right to left, depending on which works best for me. And the double bond is on carbon 2. So that's hex 2-ene. Whereas this one would have been hex
1.
Yeah. Ene. So you're saying ene means double bond, right? That double bond is on carbon 2. Yeah.
Isn't the bond in between?
Right. So we put the number on the smaller carbon. On the smaller number. I shouldn't say smaller carbon, the smaller number out of the 2. Okay? Okay. So this one, no. 1, 2, 3, 4, 5, 6, that one above. Let's just, for a review, what if that was just a normal single bond, and we just had 1, 2, 3, 4, 5, 6, that thing there. What is this named? 2-methyl hexane. Everybody okay with that? The 2-methyl hex is still true. The only difference now is I have a double bond, so I put an ene in there. And where is that double bond? It's on carbon 1, 2, 3, and 4, but we always write down the lower number. So the methyl is on carbon 2, and carbon 3 has the double bond. Make sense? Nick?
If the double bond was, let's say, on D5, would we have to say,
Then it wouldn't matter.
would we have to say 5-methyl
So 1, 2, 3, 4, 5, 6.
Or sorry, if it was on like the 4.
You still have this? Methyl?
Like,
Yeah, I know, but are you
Yeah.
still wanting the branch there?
I want like the branch like after, kind of. So like if I'm saying like if the double bond was closer, then would we have the 2 at the front at a different place? So if the double bond was at the 5, would we say would we go from the double bond first, or would we go from the
You
next
go
one?
from the lower set of numbers. Okay, how about that?
Yeah.
Okay, so now you're wondering, should I count them this way? 1, 2, 3, 4, 5, 6.
Yeah.
And then it would be called 5 methyl hex 1 ene.
Yeah.
Did you hear that? Or should I number it the green way? 1, 2, 3, 4, 5, 6, and then it's 2 methyl hex 5 ene. Everybody all right? So the question is the combination of 2 and 5 greater than or less than the combination of 5 and 1? Who wins? The 5 and 1 are a lower combination. So just like we would have done for branches, which way totals the lower amount? Same thing here. So the blue wins this naming system.
So even though the carbons are the double bond goes first for the methyl.
Correct. Okay, so you still look at the numbers like you did for over here when we had a couple different groups, and the total needs to be the lowest. So that's no different. You're just adding an extra number into the calculation. Okay, all right. So this next one is hex 2-ene. Everybody get why it's called hex 2-ene? Oh, that's the same one. Right, now look at the bottom of that page. We've got fancy name. Talk to me about this example. What do you notice? What have you learned? What can you see from these pictures? Emilio.
It's pent 1,4 diene because there's 2 double bonds.
So there's 2 double bonds. So what do we? So 1 double bond there, 1 double bond there, and therefore that has led us to what?
The numbers 1 and 4 because the first one's past just 1 carbon and the second one's past 4 carbons.
Okay, so 1 and 4. So 1 and 4. All right. Who learned something else? Natalie. And therefore we have to add a die because there's 2 of them. Who learned something else? Doesn't matter if you name it left to right or right to left. Number it right to left. It's the same, right? Okay. All right. What about this one? Is there anything else to learn from that, or is it just a solidifying of an example? Another example. Right. Just to solidify. Another same jazz. What are they? How are they related to each other?
They both have 2 double bonds.
Okay. Pardon? Yeah. 5 what? Sorry? Carbons. Yes? They do both have 5 carbons. How are they related to? How else are they related to each other? They're isomers. Do they have the same number of carbons? Same number of hydrogens? Different structure? Different name. Oh, isomers. Same molecular formula, different structural formula. It's like the thing we say. Right? Same molecular formula, carbons, hydrogens, yep. Different structural formula, different put together, therefore different name. Yep. Okay, isomers. Well done, Mike. Make sense? Any questions? Okay, so It's the same stuff you've been learning, just with a tweak, is what I said yesterday. And there you go, there's your tweak. It's this "een" with a number before it sometimes. Okay? So here is the worksheet that's going to help you put this into practice and see if you can kind of grasp it. What I'm going to do is I'm going to have you do this first worksheet, spend maybe 5 to 10 minutes on it. I'm not sure. I'll see when most people are done. Then I'll put the answers on the board. But we are going to continue on. So if you were done that worksheet before I put the answers on the board, you can continue on. Does that make sense? But I'd like to put a question. In fact, actually try one first on your own. Do the structure for just the first one. Oh, we've already done the first one. Do the structure for this one. We've already done that one too, actually. See, you can do it without looking at your notes. Go ahead on your sheet.
I did it.
You've done it? How did you get this package? Or did you were you working ahead?
Yeah, I just did something.
Good, well done. Is that what you did? Everybody know exactly that? Where'd you make a mistake, Emilio?
Well, no, I did the same thing. I just wrote CH, not C with the line 2H in the middle.
Oh, yeah, that's fine. That's fine. Either way, it's fine. Oops. Like that, you mean?
Yeah.
Yep. Fine. Everyone got exactly that?
Is it okay?
Here's
to
the
do, like,
mistakes.
yeah, this
Yeah. So, but do you have 2 hydrogens on your carbon?
yeah.
And then you've got 1 hydrogen in the middle carbon?
Yeah.
You've remembered?
Yeah.
4 sticks to carbon?
Yeah.
Impressive. And 3 at the end. Because normally people just go CH3, CH2, CH3, double bond. Right? Okay? Great, right. Have a go. I'll walk around the classroom, make sure you guys are on the right track.